Hi there, Nate. You guys can get started. I can't hear you. You're on mute.
Can you hear me, Maddie?
Yes.
Awesome. We'll start sharing our screen. Well, good afternoon, everyone. It's great to be here from sunny Thief River Falls, sharing a little bit about HDR engineering and our Thief River Falls office, as well as some work we do out of Minneapolis. As I understand it, we've got about an hour. We're going to share a little bit about some projects that we've been working on in the last year that has gone by, and then I'll focus towards the last half of the presentation on the Roseau Lake Rehabilitation Project. So at that point, we'll open up for questions, but for now, we're just going to kind of touch on some watershed successes that we've had here up in Thief River Falls. In Thief River Falls, we have 8 staff under our team, and out of Minneapolis, we have about 15 folks that work in water or water resources, and we're just so glad to be with you this afternoon. The first presenter is going to be Dylan Nelson, and he's going to share a little bit about a project that we have going on for the Middle Stake Tamarack Watershed District and the city of Newfoundland, which is in extreme northwest Minnesota. So we're going to get that going. Dylan.
Good afternoon, everyone. As Nate mentioned, I'm going to walk you through a project that's still ongoing here up in northwestern Minnesota. One second here.
Gotta have page down.
Yeah. So the 2 main engineers that for HDR that have been on this project are myself and Nate. This project began back in 2015 when FEMA came through and did a remapping effort of Marshall County, which is also in northwestern Minnesota. At that point in 2016, we were hired because what they found through that mapping or that remapping effort is that the east side of the city of Newfoundland there that you can see on the left was actually within the 1% annual chance floodplain. And this came to a shock to the residents of Newfoundland because prior to that, they were not mapped in the floodplain. And as you can see in the bottom right corner there, the issue that they were having is there's a existing railroad embankment that has 5 culverts within it. And as you can see, it's kind of a mishmash of culverts. We've got 2 96-inch pipes and 3 60-inch pipes that are quite old. And what they found was during large runoff events, there was insufficient flow capacity, so the water was inundating backwards to the east and flooding the east side of the city. So as I mentioned, in 2016, we were hired by the city of Newfoundland and the Middle Snake Tamarack Rivers Watershed District, and we performed a feasibility study to see, what kind of options the city had to remove themselves from the floodplain. That carried forward to today, where now we have a preferred alternative, and we are putting together plans and specs, which I'll touch on later on in the presentation. So here you can see another view of the floodplain for the 1% annual chance. And what I mean by that is the 100-year flood event. Through project team meetings with landowners and different agency folks, and as well as putting together a 1D, 2D comprehensive HEC-RAS model, we were able to determine that there's really 2 issues instead of just the one thought of issue with the railroad tracks. There was actually 2 issues that were causing flooding within the city. If you look north of the city, there's actually a ditch system that during large runoff events breaks out, and overland flooding comes from the north into the town, and then as it makes its way back to the river. So along with the railroad tracks being insufficient in flow capacity, they were also getting quite a bit of overland flooding from the north from the JD21 system. So our preferred alternative for this project is really a comprehensive solution. What we did was we found that having an impoundment site or an off-channel impoundment site north of the city, we could divert water from JD21 into this location and store that so that we would eliminate it from flooding the town from the north. And then we could also reduce flows within the Middle River. So within town, we would then replace that crossing that is currently 5 culverts with a new 3-span bridge with a larger opening. So that bridge would, for a short period, cause a slight increase in flows downstream, but that's offset by the impoundment to the north. So really that impoundment serves 2 purposes. It removes the flooding from JD 21 from the city, and it also reduces flows downstream in the Middle River. So here's just a slide showing the drainage area of the project. There's roughly 106 square miles upstream of the bridge within the Middle River, and then there's roughly 12 square miles for the impoundment site. So wherever we get a large rainfall event, we can capture the water and prevent it from coming into town, or during, say a spring snowmelt event, we can prevent flooding with both aspects of the project as well. So here, this picture shows the existing railroad bridge upstream and downstream on the top. And then the bottom picture is just a concept of what we're looking to do. So right now in design, we're looking at a 3-span pre-stressed concrete bridge. It's going to be roughly 105 feet in length with 30, and each span will be roughly 35 feet. So this slide shows a little bit of detail for the impoundment. As I said earlier, we're going to divert water in the upper right from JD 21 through an inlet channel into the site. We're going to also have several exterior and interior ditches just to divert other flood water or problem areas into the site as well. And then we'll have I don't know if you can see this here, but we'll have an emergency spillway to the upper right of the impoundment. And then at the south, which may be hidden here, we're going to have a gated outlet structure, which would then allow the water to release back into JD 21. So we'll be bringing it from JD 21, storing it to the west, and then releasing it back into the same system after flooding subsides downstream and releasing it to the Middle River. So, and just to touch on too, that impoundment site has roughly 2,200 acre feet of storage, and the tallest point of the embankment is roughly 14 feet tall.
So I think the key take-home message from this project is it's in final design and will be ready, shovel ready, and hopefully permitted in 2022, as long as we're able to procure state funding, et cetera, that the watershed has been working very hard on with the city. So we're excited to get this entire city removed from the floodplain. Another project that we have completed just this fall, which is kind of a fun one, is called the Oxbow Restoration. Let's see if we got the technology to get that to play. Randy Knott is going to share a little bit about what we've done here. And this is a water quality project and a flood damage reduction project located in the city of Thief River Falls.
Okay, we'll get this started. The center of the screen is an old historic portion of an oxbow for the Red Lake River. And over the years, it has been partially filled, and a lot of sediment has come into it, both being from stormwater runoff and lime sludge from the city's lime sludge plant just to the north for their drinking water. Essentially, it was overflow. And our clients are the city of Thief River Falls and the Red Lake Watershed District. The city was very interested in getting a lot of this material removed. And during our survey, one of the interesting things that we found was that there is a lot of plastics and garbage and refuse that has made its way through the storm sewer systems and is now sitting out here in this material. So our project,
If you click it.
You got to arrow down the keyboard.
Mm-hmm. All right, this is a nice plan view. The oxbow that we were cleaning is in the bottom center, and it shows the darker lines on the east side represent that there is quite a bit of fill. There's about 7 feet of material that was to be removed, and about 3 feet on the western portion. So all told, in an area that represents about 3 acres, we have removed about 27,000 acres of material and hauled it out. And aside with doing a little bit of tree cleaning around the edges and just cleaning it up in general, it's going to give us an area that's actually got a pool. And one of the more important parts of the project is preventing the floatables, the plastics, refuge, leaves, and other things from coming back into this area, because a large part of this is keeping this material out of the river, which is immediately to the west of this project under the street that's on the edge of the screen. So what we did is we installed 2 CDS structures that will intercept essentially all of the larger sediment and plastic and debris and leaves. And the city will be making an effort to keep these clean and get that material removed before it ever gets into this area. This is the continuous deflective separation. Just a quick breakdown is the water is diverted into the structure. Part of the eastern portion of this drainage area is about 1/2 of a square mile of straight urban runoff coming from the storm sewer system. So there's quite a bit of flow. So what we've got is a 2-part structure where the water is diverted out of the system and into this. And as it shows, the direct screening is catching most of the small stuff. The floatables stay in the center of the structure right up on top. Another interesting feature is that the structure is designed that below where you see the trash rotating, there's an area that oil can also be held. So that is also prevented from getting into the river. The fines essentially rotate and drop down into this bottom chamber. We're told that the standard practice for cleaning is going to be a few times a year for the floatables, and then about every 3 years we'd have to get in with a vac truck to clean that bottom out. There it's highlighting the oil and hydrocarbons that are kept in that center chamber and not allowed to get into the system. This is a picture of our big hole on the east side of the project. We're going down about 21 feet total, actually about 17 because the top of the structure is elevated. We've got the 2 structures. The upper left is our diversion structure, which has a weir in it. Because of the straight size of the runoff area, when we get a true high flow event, some of that water will have to go up and over the top of the weir. But the majority of the low flow, the low events, when a lot of the trash and stuff is going to be moving, it's going to be able to all be taken through our separation chamber. And the lower left or the lower right picture is the actual chamber itself prior to the center piece, which is shown here being installed. And this was the fun part. The contractor got out and tried to work in this area. In some places 7 feet of muck. He quickly decided that just moving out there with a backhoe wasn't really an option. So he matted the entire area and essentially made himself a matted path on which to move both a tracked truck and the excavator. And it was somewhat of a long process, but they were successful in getting all of that material pulled out and run back through with this track truck. This is also a good view of what things look like as they were finishing up. This is the eastern end of the oxbow that was cleaned out, and they were essentially just getting some of the final work done. But it's fun to be able to have a drone to get an aerial bird's eye view of what things look like. They did come back in towards the end and do a little bit of cleanup and polish work as the water receded. We built up a small area and made a crested spillway such that we can control the amount of water that stays in this area. and we'll give it just a nice feel. Instead of being solid cattails being completely choked out, we've actually got an area that I think the landowners on the north side are going to be a lot happier with going forward. So there's a good idea of what things look like pre-project versus post. Cattails that you'd never be able to see. I had the pleasure of surveying some of it, and it was not a place anyone goes. And post-project, it's actually going to hold 3 feet of water and be a lot more enjoyable.
All right, thanks, Randy. I'll take that. Now, okay, let's check back to our conference platform and see if we've got any questions. Hopefully everyone can hear us. Sounds like they can. So I'm going to quick touch on one more quick project that we think is relevant to the watershed industry, and that is called the Pine Lake Outlet Replacement. It was a project that we worked on for approximately 5 years. We even ran it through the RCPP federal planning process and looked at a whole host of alternatives. And in the end, what happened was we weren't really able to come up with any sort of retention alternatives upstream, but we did end up developing a consensus-based alternative called the incremental alternative that we built this fall, that I'm going to share with you as well as a bit of a success story for the client, the Red Lake Watershed District, and ourselves. So this was a bit of a reservoir lake. As you can see, it has a sheet pile weir dam that was managed with stop logs, and the gentleman there, great guy, Nick Olson, thanks Nick, is there operating the dam, but it was really a safety issue, and there was also a flooding problem on Pine Lake, which is in extreme northwest Minnesota. As you can see, this was just a couple of years ago, and that happened 1 out of 3 years. So this was that existing structure, and what we looked at doing was increasing the capacity as well as the ability to draw the lake down in the fall according to the operating plan. And in doing so, we came up with really a multi-purpose natural resource enhancement and flood damage reduction project where we were going to provide fish passage as well as the drawdown capabilities, which opened up 1,200 acre feet of storage in the spring to dampen the downstream retention, as well as a high capacity outlet that then could help folks on the lake. So as we worked through this project, we came to a point this fall where we had our permits, or we thought we did, and then all of a sudden we had to do some cultural resource work right at the very last minute to see if there was some concerns about buried artifacts, et cetera, which we were able to do. So what's fun about this then is, in this example, you can see we're going to have an operable dam structure on the left, and then the rock riffle fish passage in the natural channel on the right. Well, this was probably 2 years ago we made this graphic, and if you can see that in your tiny screen, this is what we ended up with this fall. And this is the fish passage weir that you can see. You're looking downstream, you can see the different rock weirs that were constructed, and this is then maybe a better view where we're kind of standing right at where the structure is. On the left would be the operable portion of the bypass channel, and on the right hand side then is where the majority of all flows will go, and over time fish will be able to pass through, whether it's upstream or downstream, pretty much 100% of the year, whereas in the past it was a fish barrier. Then one of the features of the project, and you can see that in the past you had that kind of that capacity there in the middle left where it was that size, and now we've opened it up so that when we do have an extremely high water event, we have that much more capacity to try and protect over 50 cabins then that are on the right hand side of the lake, east side, northeast side, and that's really the multi-purpose of the project. It also provides operational flexibility with the gates, safe access, more response time and safety. And then, like I've already mentioned, fish passage. So this was really a great project for us and for the Red Lake watershed. And then we do have another phase that we're going to consider throughout the winter and into next year, where we may look at some snagging and clearing of the downstream channel, as well as adding a culvert capacity at one or more crossings, working with the county highway department to kind of complete the overall design of the project, which is to have upstream benefits and downstream benefits in its entirety. All right, so that's a little bit about what we do here at HDR Engineering. And now for the feature project, I'm going to talk to you about the Roseau Lake project, and kind of a lifelong pursuit for me personally. I've been working on this project for about 10 years, and I think we're finally to a point where we may actually have the possibility of phase 1 construction next year, 2022. Your typical water management project in at least the Red River Basin is maybe at best a 5 to 6 year project. You can see that you've got planning that goes on early on, then you've got some engineering, and then you start your public outreach, and eventually you get into environmental review, permitting, etc., and finally with construction. And then you can see along the bottom there, you can also see where a lot of your funding comes into play. Some of it's the watershed that it starts out with, and then it builds and builds, and hopefully you find other funding sources like the Red River Watershed Management Board, Minnesota DNR, flood hazard mitigation, etc. Lessard Sams has become a major player, as well as lots of other entities that work with us on funding these great projects. Okay, well, that's probably the best case scenario. Here's the Roseau Lake Rehabilitation timeline. You can see how busy this slide is, but I really want to point out is that it really started back in 2011, and we won't spend any time focusing on that. But now we're getting to the point where hopefully we can look at construction next year. Well, how does a project like this start? Well, in the case of this project, it started out at the Citizens Advisory Committee level, where they actually did, this is like pre-technology, they did a survey where everybody had a little handheld device, and I don't mean a smartphone, and they answered about 25 questions, and they voted on what they'd like to see. And so we were able to kind of build the purpose and need of this project by a survey of all the stakeholders that would be involved. In this case, it was flood damage reduction that was probably the most important, and then enhancing fish and wildlife habitat. Well, then we got into some of the details of, well, when should this, in this case, the lake bottom, be filled? Because it was already a basin that had been drained during the development and settlement of the Roseau area, and now it was just kind of flooding indiscriminately every other year, if not every year. And so we asked questions like, well, when should this be enacted? When should this design actually accomplish its goals? And you can see in this case, we had a kind of a 1/3 result, but pretty much anytime ag land was in jeopardy. And just another example then would be, if you're going to do a flood damage reduction project, what is the multi-purpose, the natural resource benefits or enhancements that you might consider? And here the group kind of agreed, well, maybe we could do a shallow lake management type habitat with just a little bit of water in the bottom, such that you would leave the majority of the water around for flood storage and so on. So through that process, we developed a summary of the problems with the existing condition. And this is, you can see in the background photo, this is what this Roseau Lake area looks like now, and often floods both in the spring, summer, and sometimes even in the fall. Twice on record, it's flooded to this extent in the fall. And then through the project team process, we developed FDR and NRE goals, which certainly you can read these, and you can also imagine these are pretty common to what you might imagine, but it's really a robust project with truly a multi-purpose emphasis in partnership with Minnesota DNR. In fact, I often tell anyone who will listen, this is mostly an NRE project with the DNR partnership as well as others. And then the flood damage reduction comes in to complement the project design. Well, the strategies that we have used then with this design include drainage, protection, diversion, and retention, really the four pillars of any sort of flood problem solution. And we'll get into a little bit of that as we go forward. We did our alternatives analysis over time, looking at all kinds of different impoundment cells, diversion cells, and how to bring the water, when to bring it in, etc., to the point where we came up with a concept. Right now, this Roseau Lake floods indiscriminately as it is out there in nature. And if we could just move the water down a little sooner in a hydrograph and then save that storage for a little bit later, we could actually accomplish both a peak flow reduction and a duration reduction for the entire area, both adjacent and downstream. It would not increase flooding, it would just change the timing of how that lake operates. When we looked at the various alternatives, we looked at the benefits, of course, that were apparent. We looked at cost. We looked at wetland and other environmental impacts. We looked at the complexity of the operation and maintenance of various alternatives. And then ultimately, we used a consensus-based process to really drill down and come up with something we thought everyone could live with. We had a lot of screening that went on in various examples to see, well, which alternative would get us the most stars, if you will. We also looked at local effects, whether it was the downstream floodplain, the actual hydrographs for very frequent events, and what would the benefits of the project be for the farmers as opposed to any roads, bridges, or small cities or farmsteads downstream. And then we looked at, and as you can see, this is a topographic map that shows a very flat area adjacent to the lake, but we looked at, well, what would really move the needle for landowners adjacent. We looked at dike height. We looked at individual landowner heights and how the project could benefit them. To the point where these stars are shown, we made as much as 10 different adaptations of the project design to address project team and landowner concerns. And we had a lot of public meetings to the point where this is what we really came up with as a project design. Is it has frequent flood damage reduction benefits up to about a 10-year, 10-day event benefit in terms of reduction of depth and duration. But ultimately for the larger floods, we really couldn't bring anything to the table that would just kind of be washed out and negligible for those large, super large floods. But it would still have all the natural resource benefits as well as those frequent benefits, which really was the problem for the landowners in the region. So another way to look at this is what it looks like now with the alternative that we did come up with, which simply put is called Alternative 1. And that's what it looks like now. Okay, this is just a aerial image of what happened in 2019. And with the project, what we're able to do then is store the water north of the north embankment, while the other areas to the south and downstream are allowed to drain away, while we have that gated storage upwards of 20,000 acre feet that right now it would just be competing to get back into the river and would be continuing to flood for weeks adjacent and downstream. So when you compare the benefits of the proposed and the existing conditions, you've got the peak flood reductions because of that change in the timing, the duration reductions, which could help with springtime planting. During the growing season, we can also have reductions because now the Roseau River itself can reduce and drop quicker so that it is an outlet for adjacent farmlands. Okay, those are the benefits. And then there's just a hydrograph where you can see, for example, for these more frequent events, you can see the peak flow reduction here, as well as then the duration reduction that occurs here in the horizontal axis, which every day matters. So we have, for a 2-year event, as much as an 8% reduction in peak flows downstream, and so on. Through this process, then we've ended up, like I said, screening to an alternative that the Roseau River Watershed Board has chosen. This project has been incredibly challenging, but worth the effort. Then I'm going to touch on what those challenges have been and how important this project is when we circle around to the fact that we've almost applied for permits now coming up this winter and then moving towards construction, really a phased approach next year. One of the things that we've done over the lifespan of the project is we've done a lot of public outreach and communication. We've had several public meetings. We have information on the watershed website. We also have issued newsletters that have project information, frequently asked questions, and the like, as well as the project team process, which was followed for really the life of the project. We haven't had a project team now in about a year, and I'm not sure that we will anymore, because as it's an advisory role, the project is essentially designed and really under the implementation phase in accordance with the board's direction. The project had a lot of unique features, but maybe one of the most challenging feature is the borrow plan and how we're going to actually build these embankments in an extremely wet environment with somewhat changing and varied soil conditions. We of course, when we're going to build an embankment, you want it to be stable, you want it to be impermeable and stand the test of time. And what we've probably spent about 2 years working with Minnesota DNR on a natural resource and borrow plan that really gives them lots of features that they like to see with their natural resource management, up to and including shallow habitat. None of those dark areas shown there are going to be deep pools. They're all going to be, in the end, just a few feet deep, filled back once we've taken our borrow. And then we even have essentially a sinuous borrow channel shown there on the western end here that's going to be used as well, that suits their purposes for the goals of the project. We've developed a maintenance plan, which there's about 20 miles of embankment and project footprint. So you can imagine there's a lot of work to be done and planned in terms of who's going to do what. Is the watershed going to do the work? If there's some structural work necessary, is the DNR going to do the maintenance, and so on. And so that was something else that we developed with the project. We developed a recreation plan that involves all the things that will go into a feature like this for the public. It'll not only just be for hunting, it'll be for bird watching, possibly fishing, camping. Anything that would go on here is incorporated as part of the plan of this project and has been worked on by both the Minnesota DNR and the Watershed District. We developed an access plan wherein you not only have private landowner access, you've got public access, and who's going to go where when. And with a project that has a footprint this large, I think what you'll find is it gets to be incredibly complicated to meet all the competing needs, whether it's recreation, access, maintenance, flood damage reduction, or even really for the wildlife, because there are also sanctuary areas in this project that are a part of the design. So all these moving parts have really led to finally then a large-scale project that has a mitigation plan to boot to the north of the site that will provide really what amounts to a self-mitigating project. We don't plan at this point to purchase wetland credits or anything like that. We're looking at a net functional improvement of the wetland environment, and we haven't applied for the permits yet, but all of this work is well underway and in its final stages of completion, up to and including the river restoration. Right now, there's a cutoff channel that's in existence on the south side of this project, and that cutoff channel will be blocked up to a certain elevation, such that up to about a 1.5 year flow will always be then shunted down the original historical channel of the Roseau River. So we see tremendous advantages to the Roseau River itself, as well as the wildlife purposes of this project in terms of its environmental and natural resource capabilities. You take a project that's this large with a lot of moving parts, and we've broken it into 3 phases as well. The construction, and monetarily, we don't necessarily expect that we're always going to get all the funding all at once for this project. So we have 3 separable independent phases that we've worked on, in addition to all these other moving parts, to hopefully be able to show that as funding would become available, we can have meaningful utility and progress with each phase. Then I should also mention that the Lessard SAMS is also providing grant monies towards this project. Then we bring ourselves kind of full circle to another challenge of this project has been an environmental assessment worksheet that we've done, which just recently completed here this past summer, whereas the record of decision was that we don't need to do an EIS for this project. The environmental review process was complete, and we probably spent a year or so working on that EAW and another year or two getting it completed. But it was a great effort working together with Minnesota DNR and other partners, and we're happy to say that the record of decision was issued. So back to how I started on this project is easily the most complicated project I've ever worked on, easily the longest term project. We're sitting at about 10 years and counting. But with that said, when you have a committed client and a committed partner and realistically a committed state, because whether you're talking PCA, Board of Water and Soil Resources, Minnesota DNR, et cetera, everybody's been there along helping this thing move forward. Then it's very exciting to see then when you get right down to the end here that funding, of course, is pending and permitting will be applied for. We're very close to implementing this very important project. And this is kind of just an overview of what this could look like. There's little examples of the structures, and maybe I'll just focus a little bit on that, which I haven't spent much time on this presentation, but you basically have a northwest embankment and exterior drainage ditch around the outside of the project, as well as this north embankment here that's all on public land with the minor exception of a few private parcels that we're working on acquiring. And then you have this inlet channel here with a structure right next to the Roseau River. And then you can see down here, this is that cutoff channel I mentioned to earlier, which when we block that up to a certain elevation, then all the flows will then be able to go around and through the existing Roseau River. And I should add that this is a known excellent walleye fishery, northerns, et cetera, in this area. And this will only help but enhance that aspect of the project. So I think with that, Maddie, I think I'm kind of done, and we could entertain questions or really I could keep talking about the project, but I think for now, that's about where I'm at with this presentation.
Yeah, that sounds good. I'm looking at the chat right now to see if we have any questions. Okay, we did have a question from Rob, but it looks like you guys covered it.
Yeah, I think what I would add to funding is that the project isn't completely funded yet, right? There's a lot of work to be done on that aspect of it, but in terms of what happens in the Red River Basin and working with the Red River Watershed Management Board and the DNR Hazard Mitigation Group, we really optimistically anticipate funding. It may take a period of years, but the project has been approved by the Flood Damage Reduction Work Group. It's at an approved step 2 of the Red Board, as well as other organizations. The Retention Authority, et cetera, is in support of the project, as well as Roseau County, the city of Roseau, have all passed resolutions in support of the project. So we'd like to think that as long as we're shovel ready, especially with this upcoming infrastructure coming from the federal side of things, we anticipate that a lot of shovel ready projects are going to see some success down the road here if we all just do the work up front. So I see a question back to the Oxbow question and project. I think what is asking were the CDS filters prefab, and yes, they were delivered on site. I believe they came through Contech.
Correct.
And there's other vendors out there, other suppliers, but those CDS filters, they're not inexpensive. They can be quite expensive, but they're becoming very common, especially in more urban environments. And in this case, they actually had a specialist fly in from Texas to help the contractor install the inside fiberglass components that make it work. And apparently there's some, you know, nuance and sensitivity to that installation. And he was literally in Thief River Falls on site for an hour. He flew up from Texas, was on site for the installation, and he flew back. So sounds like a pretty good gig if you can get it. And there were 2 of those CDSs installed on that project, one from 2 separate drainage areas. And that project has also been acknowledged by Bowser. It's been written up and represented in terms of its overall uniqueness and its water quality benefits. And we'd be excited to talk about that at a future date as well.
All right, any other questions? Feel free to unmute yourself at this point if you want to just directly ask a question. Otherwise, you can still use the chat function. Okay, I don't see anything else popping up at the moment. So I just want to thank HDR for taking the time today to give us this presentation. We really appreciate it. I am launching something in the chat right now for the next session that is starting. Oh, I will share it with everyone. We do have the Sip and Share networking event starting at 4 p.m. So in the chat function, you will get the link to access that event. Otherwise, we plan on starting again tomorrow morning at 9 a.m. Thank you all so much for attending, and we hope to see you at the Sip and Share event.
Thank you.
Thanks, Nate.